So good morning, everybody.
Good morning, Kim.
Good morning. Data day. Hot data day. I've been playing around with these slides just trying to describe where we are and what we're doing. So it's hot, big BIM data. It's kind of the theme. And also the data declaration of independence. I'm playing off of some themes that have been floating around about interoperability and access to data and what owners want with the data. And I'm part of, just a little bit of background, I'm an architect, and I've been using BIM since the early 90s. And before that, we were into databases and 3D. So this has been a very long journey for us. And in that process of being an architect using these tools, we started realizing very early on, actually, in the mid-90s. Well, first of all, we got into the internet in '94. So we jumped right in and figured out how to connect because we needed to connect with offices around the world and other partners. And so that's been a driver. And in doing all that, we started morphing into a software company as well because we were developing our own tools, which gave us a deeper understanding of what all this is about because we needed information to flow between applications, for example. And then owners and clients started saying, wow, you guys are doing pretty interesting things, 3D, and oh, there's some data there. Can you help us do visualization first? And that started in the 90s, and then BIM and connections to data. And then we're ending up now where we're doing kind of the range of things. But the most interesting part that I hope to bring today was from a strategy point of view. We're consulting to some very large owners that have very large problems that apply across the industry. And we want to share that with you. So the owners will be going through, and you'll see what we've been doing with that. So it's a lot of different hats I'm wearing. And the last hat I wear, I work with a lot of standards organizations with Building Smart Alliance for many years, chair of technology and architectural practice at AIA. I've had my disagreements with all the organizations, including Building Smart. In fact, that's this Data Independence Day theme is about, I'm very much into standards. Standards are great, but they also can hold us back if they become too restrictive and too brittle. And Jeremy actually touched on a lot of these points yesterday as well. Actually, this is a good, I see a lot of familiar faces, but who was here on Monday and Tuesday at content? Okay, so about half of you. So I'll try not to, I want to reference some things that we heard there, and I'll try and recap some of the ideas that we saw. So the eye of BIM and data, or data, is going to be the focus today, and the eye of BIM and big BIM as well, big data. And I think this is a huge, huge opportunity for us as an industry. If we can really grasp what does that really mean and how do we fit into it, it creates tremendous value for a lot of different stakeholders. So this is where we started. This is actually an actual slide from an actual project, a very complex project for a healthcare owner that we sat in with this design process. And it was a very painful process where they were putting paper on the screen and saying, what does our existing building, where's our radiology department? Do we call it 286 or is it 276? I can't remember. So this very simple connection of what do we have and what do we call things is kind of universal, I think. Just understanding what we have and what we call it is a big problem. And in today's perspective, with all the tools that we have, this is almost laughable in many ways of why are we still doing things like this? And even if we look back at a schedule like this and looking at the type of a door types, for example, or equipment types, the concept of type has been around much long before BIM even existed. But we hear a lot of complaints or moaning and groaning in COBie deliverables of tracking types in a building. And it's not a simple problem, but from a data perspective, it has existed long before the technology has been with us. So then the other challenge is just the finding stuff problem. And the stuff can even be digital files. This is an actual website that the Department of Veterans Affairs uses to communicate their standards and requirements of how they design hospitals. And they have stacks of documents, PDF files, Excel files, Word documents, BIM files, in many different formats and many different age groups. In other words, a lot of it is 5 years old. Therefore, a lot of it is just static information, even if it's digital, even if it's a BIM template that was created years ago that really is no longer relevant to what's happening today. So as a designer, if I put the designer hat on or a builder or whoever, try to go in there and understand what this owner wants to do, it becomes very difficult to achieve that. So this finding stuff problem. And then in some of our studies that we did with owners, the numbers are just staggering how much waste there is. It's just absolutely amazing. This is the Department of Defense, just a little sliver of what they do for managing work orders. They manage, in the Department of Defense, a subset of the Department of Defense is the healthcare portion of the Department of Defense. They manage 783,917 work orders a year. This was from 2012, and it's grown since then. And they do this process of running back and forth. We've all seen this. What's this thing called? Okay, we got to write it down and take it back to a computer, type it in into some antiquated system, and go back to the field, and all this stuff. And we calculated out what's the cost to the DoD of $113 million a year. This is just for going back and forth and tracking stuff. And this is just a small sliver. So this is an opportunity, again, of if we can figure out how to make this much better. So I'm going to play a short video here.
The architecture of building-informed environments. In 1983, Korean Airlines Flight 007 strayed into Soviet airspace due to a navigational problem and was shot down. That same year, in the height of the Cold War, President Reagan mandated through an executive order that the Department of Defense Global Positioning System, GPS, and satellite system be opened up for civilian use. For the greater good of safer navigation throughout the world, GPS was opened up and has had a huge impact on us today and how we navigate our world. When I visited the Trinity College Library and looked at the knowledge of a nation in analog format in books stacked 2 stories high, I imagined crossing the green ropes and climbing up a ladder to get to a piece of knowledge in a book. Data in analog format is no longer an efficient way to share information in our world today. Change and innovation are happening at a staggering rate. There was a Kodak moment in 2002 when digital cameras overtook analog cameras with the very technology that Kodak invented yet suppressed. Kodak lost focus on capturing and sharing memories with a business need to sell more paper and chemicals. Now, not only are we taking pictures, but we're locating them on a map through GPS. Location awareness has allowed us to find things on maps like Starbucks and has changed everything about how we navigate the world around us. Location awareness enabled by GPS is the foundation for the Internet of Things and smart cities, and access to real-time data such as finding the next bus, reserving a hotel, finding where our friends are, Googling everything. Data is stacked everywhere around us, and we expect this level of interactivity. It is no longer about one person trying to find one taxi on the street. It is a swarm of drivers networked through applications such as Uber that find you the right ride at the right place for the right price. This has fundamentally changed transportation in the city. Uber has overtaken taxis in 2015. They use the same global positioning system and other technologies combined together to bring you real-time access to rides. In this rapidly advancing world of smart cities and Internet of Things, we are all connected, but there's one gaping hole. The building industry has been overtaken by the technologies around us. As architects, we need to embrace the new tools and processes and change that's happening around us. When I look up, I see buildings, but I do not see the data yet. It's missing. We need to figure out how to make it front and center and connect to the world around us. Architects already process this complex data that can be incredibly valuable for this interconnected world. Even with building information modeling, though, it's very much a file-based and project-focused format. We finish the project, we file it, and the BIMs are used to process information just for that one use. But the capability exists because the information is there, it's just in the wrong format, even with BIM. The complexity of the building industry has required structure and order in the tools and processes that we use to capture the knowledge and decisions that we make. But let's not let the tools from the past limit what we can do with the data today. Knowledge trapped in an analog canyon of books or buildings is still valuable. We are in an incredibly unique position as architects, planners, and engineers that know how buildings and cities are put together to help structure and extract that data in a format that is valuable for others and link it to the technologies that are surrounding us. In this post-analog world, data and knowledge does not have to be stored and retrieved in a linear format. Cloud technologies and web services that drive Uber and other applications can be used to stream data from the cloud from BIM and support the Internet of Things in smart cities. BIM can link to it along with other information, but it's not necessarily at the center. Looking at bits of information as raindrops, one can then combine information to create new patterns, and machines can help crunch through those numbers to help us identify those patterns. So why did I tell you this story about global positioning systems and the technologies that are changing around us? The reality is that the building industry is already going through a shift, and this is an opportunity for owners and architects to help drive that. In our consulting work with owners that
I'm going to pause this there. This is on the internet, so you can actually watch the rest of it, but I'll be going further into some of these concepts. And one challenge I have today, as was mentioned by Chris when we started up, is we have this kind of strategy focus, and then we also have a deeper kind of technology focus. I'm going to try and hit both sides and still make it understandable, and hopefully generate a dialogue and help with the objectives as were outlined in the introduction. Jim Dieter, the executive director of the Asset Leadership Network, has this great quote. He says, "You can divide assets into people, money, and stuff. A lot of resources has been spent on managing people and finances, but there isn't as much effort into managing stuff. And the stuff is everything about the buildings, the stuff inside the buildings, the fleet activity that manages an organization. All of that stuff is basically data that we can help pull together." The other is, this is a journal of the National Institute of Building Sciences, and John Roach is the vice chair on thought leadership with me at the Building Smart Alliance. There's this great article, it's free on the web, called "The Center of the Universe is Lonely." And I'll be hitting on these themes as well, too. It's this idea of where do we store this information and how do we get to it? What application do we use? What system do we use? And you end up with pockets of different, that's what this red, green, and yellow are all about. You end up with pockets of different ecosystems that don't necessarily connect to each other. And the message that we've been pushing out there is really, if you break that apart and you neutralize the data, the applications really should not matter at all. They should be disposable. This is a funny thing coming from a software developer to say, but even our application should be disposable. You should be able to, as an owner, unplug an application, plug another application in, and still maintain the consistency of that data. And if the data is neutral like that, then you can access it from anywhere, including future applications or future functionality that we can't even imagine today. We can't predetermine all the different file exchanges that Building Smart is trying to define before we know what's really going to happen. And that's one of the challenges. We're constantly, for years now, trying to define all these exchanges and document them and make them very rigid and standards focused. And Jeremy actually had a great quote yesterday about, well, let's just crowdsource standards. There's no reason to define everything. And I completely agree with that. There's this, if you have this basic structure, the Department of Defense, when they opened up their global positioning system, never imagined that Pokemon Go was going to use the GPS system from the DoD to play games. But it's a perfect use case. And it's a huge market for them now. So that's an opportunity. If we think of data as neutral and we can pull it into anything we need, then the world opens up. So BIM Babel, there's a lot of, what format do we use, what applications do we use, what COBie, what IFC, all important stuff, but it becomes just noise, like Chris said. It's all these acronyms just get in the way of allowing us to really meet the objectives that we have. Program to BIM is, I'm going to explain some of this as we go along, but how do we start this process? And this is actually a diagram. We worked with the Coast Guard and the Homeland Security. This is from 2004. A sketch, they called it the airplane sketch, because I sketched it on the plane before our presentation in the morning, conceptually to say they were just starting to get into BIM. They said, well, what level of BIM do we need to manage our information about our facilities? And I said, well, you can even start with just a block that says I have 495,000 square feet in this location, and it would still be valuable because you can start querying it and saying, well, what kind of square footage and who's there and all that. Or you can work all the way up to a very detailed model and still have the same data. So conceptually, that data along the bottom can fit into any of the applications above. And this was part of a roadmap that was defined for the Coast Guard. They were very early on into getting into to BIM and the use of BIM. And the concept of layers of information and levels of detail and all that LOD work that's been going on today as well, too, in the industry. So backing up, the Coast Guard had an interesting quote at the time that we identified this. So the data about our facilities is more valuable than the physical facility itself. If you look over the life cycle, the building is just a box. It's an asset. It's an important box. But the data that churns through that box is more valuable to the organization, because if they don't know what's going on, how can they make decisions from a business perspective? And this applies to any owner, any size, I believe. And I'd like to present next, this actually received an award at the National Press Club and Asset Leadership Network. This work that involved a lot of different groups. We were involved with it as well through the National Institute of Building Sciences. But we worked with these owners that are healthcare owners, the Department of Defense and Department of Veterans Affairs. And if you pull the word healthcare out of there and pull the word DOD out of there, you can basically plug in anything else and it still applies. It's about information in the building, and where do we start cataloging information and organizing it in a way that we can actually use it. So in healthcare's case, they have stuff inside an exam room, a dental exam room, that says, in order to do a dental surgery, I need all these things around me. And all these things that are required to do a dental surgery are constantly changing because the technology and best practice is changing. And we need to communicate that out to the design and construction teams to build these facilities for us that meet our business objectives. So their data of their business requirements connected to the way that we communicate out to the industry, and then we check it and manage the facility. So it's not a single use case, but it's conceptually, if we keep this structure, there's a ways to do this that would help manage their inventory of information. And these bullet points are actually from a playbook that we're going to be using for, I'll explain later in the BIM storm, that explain the basic plays that you need to do as an owner, as a designer, to manage information. So step one, whenever we walk into an owner organization, they say, well, we need to use BIM and we need to manage data. And we said, okay, do you know where all your information about your facilities is? And it's usually, as we all know, in different silos in analog format and BIM stuck in a drawer somewhere. And we said, okay, collect it out, put it in a list of some sort. I don't care if it's in Google Docs or whatever. Share that information, and then create what we called recipes or rules of what's the relationship. What type of equipment goes into a dental exam room? What type of attributes do we want to track about our equipment as we go into the life cycle? And then mandate. Mandate basically require the use of that data in a consistent way so you can manage it over time. If you don't mandate it, then you end up in many different silos. So this concept of data and going throughout the life cycle, if you strip away, are we doing programming, planning, design, construction, operation, you take all those words out and you imagine the information, it applies at all levels, all the way from the strategy of why are we managing these type of facilities, why are we building these type of facilities, what are we building, how are we building it, what is built, what got delivered to us, how is it functioning, and now lessons learned and bringing it back into the first part of the life cycle. So there was a series of projects looking at digesting all of that and identifying opportunities to change and making it available to the different stakeholders. So this is a concept about, if you think about all the type of data that goes throughout a life cycle, you have many different stakeholders, including contractors, design architects, design builders, and facility managers that need access to that information. So from a BIM, for example, obviously we're all very well versed, I think, in how we use BIM to do design and construction. There's obviously struggles with that. But then if you strip the data out of that and you think, okay, you have customers in a hospital that are trying to find this room or this part of the hospital, it's that bit of information that they want to get to say, where's the radiology department? Or the executives that want to do a roll-up and say, how's our portfolio of facilities doing, which a lot of owners cannot do, especially in government. They can't do a roll-up and say, how many square feet of X do we have? Or what's the condition of our laboratories? Or where are we deficient in the type of equipment that we need to do medical procedures? That type of thing is not accessible. So we're starting to process things on the design and construction side that's creating huge amount of data that is valuable to the owner organization as long as we can deliver it back to them and as long as they can consume it in a way that's valuable to them. How many are familiar with the UK BIM maturity model? Okay. So this is going to, I like to be controversial, and I've gotten in trouble for this in the past, but I think it's time to actually cut to the chase and actually push things out and say, where are we going with all this? So this is it's been a great thing because it's raised awareness about the type of things that go into, you start from CAD, you go into 2D and 3D, and the 2016 mandate says that you'll start using file exchanges with open standard formats. Wonderful and very important. I'm not saying this is bad, I'm just saying that's where things are. But the part that I think needs to be looked at again, the concept of a level 3, which they're not there yet, is where the data button is right now, which kind of implies that we can't manage data until we get to level 3, or we can't manage processes, or we can't manage the life cycle. And I think that's a problem, just conceptually. Even if it doesn't intend to spread this message, it is spreading this message that we can't get to level 3 until we perfect level 2. So it's a very linear progression of building up standards and building up capability, which is no longer valid in this world around us that has completely changed. Everything has changed about our expectation of access to information, being able to do stuff with information. So I want to shift this a little bit and say, okay, what if we break this up? All these concepts are great, but what if we try and break this up and do some cross-cutting? And my belief is that data is valid at any level. Even without any 2D, it's valid, right? We do that with our mobile phones. We don't have a 2D map of the building or to find information about can I reserve a room in this hotel? That's a location-based thing without a model, but it's related to this location, so I can reserve a room in this hotel. So it's valid at any level. And if we think of in these terms, that means there's opportunities, there's low-hanging fruit to focus on the data and think about how it moves its way up into level 3. We call this minimum viable BIM. How many have heard the term minimum viable product? Okay, in software development and agile software development, which is the way to go today, you start in small increments and you start building functionality rapidly and just put it out there. And if it fails, great, you just throw it away and keep moving and build the next thing. If the interface is no good, you throw it away. You keep iterating and building. So minimum viable BIM, we're not saying it's minimum in functionality. We're saying it could be minimum in geometry, but maximum data and impact, big data. And it's not bad if you have maximum 3D geometry as well on top. It's not one or the other. It's just both. The linearity of this diagram implies that you need a lot of geometry and a lot of BIM to do great stuff with processes and the life cycle, which is absolutely false. So cross-cutting to get there faster allows us to create value and identify how we fit into this ecosystem, how we can bring value to owners, because we're already there. We're already dealing with the data. So let's just run to this. So the maturity model, I said, what if we shake this up a little bit and kind of turn it on its side and think in terms of the web services that have been referenced in level 3, the data, the processes, the CAD, and build these up like little Lego blocks. And take this and basically shift it 90 degrees. If we rotate it 90 degrees and then break this apart and say, okay, there's applications. There's different applications for CAD, 2D, 3D, BIM. And remember that I said applications are disposable now. It's no longer you have to buy in. And it's going to be a hybrid environment. We're obviously going to be using a lot of very powerful, very important applications for BIM and CAD and whatever. But if you take the applications and you decouple the data from them, and you think in terms of, okay, what happens if we can get to that data, regardless of what application we use? Most applications that have been built in the past, they fuse the data to the application, and they try and sell, and this is coming from a software understanding of how things are happening in the software world, they sell you that functionality and say, look how great the tool we have, put your data in our tool, and use our tool forever. And if you want to leave our tool, we're going to make it very expensive and painful for you to take our data and move it into something else. Then we start talking about standards. We need standards, because of this complexity, we need standards to cross-connect and exchange data, COBE, IFC, XML, DWG. These are the standards discussions that have been happening for years. We need to standardize on what we call things so we can get data from one application, BIM application, to the next. All important stuff, but it's still a file-based exchange. It's still a file-based exchange of getting stuff out of a big application into another application. We do not do file-based exchanges with our mobile devices. We don't go to an airline scheduling site, to Expedia, and download the entire flight schedule for the day into our mobile device and then do a search. We do a query. It hits a database from multiple vendors, multiple databases, and brings us options, which we then push a button, which then does a transaction with a bank that buys us that ticket on that plane. That's the world we live in today. We don't live in a file exchange world. The building industry still does. So we have to figure out how we break that challenge. So if we decouple the data from the application, this is essentially a level 3 discussion. And then we build web services, rules that say, how do I get to that data? So if the data is neutral and there's ways of how do I get to data, it means that Jeremy can go and build applications to build 3D gaming engines that get to data. You don't really care where it came from. You can start just molding it together. Or Pokemon Go can come and say, well, I see a mapping application, I have a gaming thing, and I could build a game application. It's not a BIM, but it's a gaming application on a map. That completely opens a whole new world. And these applications that are being built out there today can be built in just minutes or hours in many cases. Very simple ways to build simple mobile devices access applications. So and this is another misconception. Data does not have to be in one giant big bucket in the center of the world somewhere. That's a fallacy. It's going to be in multiple locations, authoritative sources of information. So airline schedules, for example. Delta has a database of flight schedules and their strategy of how they price tickets, and American Airlines has this as well. And we use our apps to say we want to find a flight. We don't care where that data comes from, but there's stuff happening in the background. Meanwhile, from the business side and the strategy, somebody else is opening up a dashboard at Delta and saying, wow, there's demand going up here, and we're going to change this, and there's algorithms that do that negotiation. So all that stuff is happening. It's starting to churn either automatically or through people interacting with it. The web service about how you get to that data does not also have to be in one central location. It could be a bunch of different web services. These are basically the rules that say if you are a consumer of flight schedule data, then you can go and search for flight schedules and you can buy it. If you're a Delta executive and you want to see how are you doing with pricing your tickets, then you can get to that and see what's going on. If you want to look at the weather data and see what the risk is of flying planes in this part of the country, then you can go and find the weather data that's public on the web. So it's a combination of tons of data out there and tons of data services, web services, that allow us to do this. So what I just described is the world that we all live in today for many years. We're already doing that with our mobile applications, and the challenge is how do we shift the building industry into that world, because that's where the opportunity really is. So what I just described here is not just a theory of where we're going to go. I'm going to show you bits and pieces of this. This is already starting to happen. It's starting to happen in ways that is creating new opportunities. Even in the last few days at the Content Summit, I've had discussions with different Lego blocks on top of different applications that can plug into this. And that future functionality, we don't have to predefine. Future applications are going to start jumping into this. More consultants, builders, architects, and others are starting to build their own applications and plug into this, and I think that's the opportunity. So that's a commentary on the level 3 maturity model, which I think it's fantastic what's happening in the UK because it's pushed the discussion forward, but I think we need to jiggle it a little bit and look at how we relook at that. So everything I described about this 3-tiered architecture, there's actually a White House document called the 21st Century Digital Strategy. It's public on the web. It describes this information layer, the data, the platform layer, and the application layer. And the application, in the government's case, they're saying government applications need to follow the same rules because they're built in different silos and you can't share data within even a single agency. And we also need to be facing the public in some cases and share some of the government data out to the public. So this structure, this architecture of the 3-tiered architecture is not something the White House invented. This has been out there. This is how the web functions. So it's a natural fit for us to bring that world into the building world. So this is where we live today, right? We're on our mobile devices. We want apps. We want data. We want web services. We want to plug and play things. And we don't want to be locked into applications. We want to be able to make them disposable and plug in another Lego block. All these Lego blocks start plugging together as they start working with each other. And the minimum viable BIM, I believe, is an opportunity to think in terms of how do we, if we think of the full BIM, the complex model and what we use for design and construction, very important. But if we strip it down to what is the minimum that we can start with, there are opportunities today. We don't have to wait for everything to be perfect. Okay, Moneyball. This is Mark Sands from the He's on the thought leadership at Building Smart Alliance, wrote this great article on his blog. Moneyball is, how many of you have watched that movie or know this story? So as we know, once you can get access to information, you can start changing decisions that you make about strategy for baseball, right? And that changed baseball forever. If you can get access to data and see the patterns, you can see new things that you can do with that. So we played with that a little bit and said, what if we call this a BIM ball? If we think in terms like that, how do we look at BIM in a different way to analyze the data and do new things with it? So if you can pull out your mobile devices, we're going to do a little exercise here and log into this. This is a simple app that was initially built over the weekend, essentially, and it's grown since then. But the reason we built this was not to say, well, we're going to build a work order application. It was more when we were working with owners that were struggling with managing information about their facilities and were stuck into monolithic, proprietary tools that didn't let data flow back and forth. And it was to demonstrate to owners like the Department of Defense and VA what you can do once you start thinking in terms of apps. So you can actually submit a work order here. And I'll explain what you're seeing. I'm not going to explain first. If you put different hats on as we're going through this, the person that's in the field doing a work order, they could care less about BIM or data or web services or all the stuff that I described to you. They just want to say, something's happening in this room. There's water on the floor. And actually, I'll go through and do it myself here. Let's go to anuma.com/workorder/BIM. Any questions? I've been talking a lot. Maybe I'll pause here if there's any comments, any shout-outs you want to say, questions, comments, or I'll just keep rolling. Okay. All right. So what we're seeing here, you don't have to put your email address there if you don't want to, but I'm going to put my email address. You don't have to put your phone number. This pull down and just select clinic, say, and then when I say, okay, I'm on the first floor of this clinic, and I'm in a room here that has something going on the floor, an exam room, just pick anything basically. So that pull down, and I'll explain what this is about. This is actually hitting, the origins of this data are coming from a government server. A government server with data that was only distributed by CDs 3 years ago. They used to distribute their standards of here's what we call things by CDs. But now that it's consistent, then we can say, okay, I'm going to submit a work order, water on floor, whatever. As I selected that, and this is accessing multiple different plugins and iframes of different viewers. This is a viewer for a floor plan, so it's showing that I selected that room. It knows that I'm in that room because we've agreed on the room number. So standards are important. It's not that I'm saying don't use standards. If we have consistent room numbering, then at least we can say things are happening in that room. Jeremy, you referred to this too as well too. When you have different things of numbering systems and you can't find things easily, and that's a struggle that we have in the industry. At least, let's say we're in this room and something's happening in that room. That should be a very basic concept. So if I hit submit here, so this is going and submitting it to the cloud. There's your request, and then I'm going to get into the more technical side of what's happening in the background of this, because I think that's the more interesting thing here. So what we just did was submit a work order, and you can submit a few if you'd like. So there's a web service in the background here. This web service is coming from a government server with data that used to be locked away that nobody could get to except if you were in the DoD or VA. These were their standards of what they call things. And we said, okay, if you want to get a consistent naming and numbering standard for an exam room, don't put it on a PDF and post it on the web and make it obsolete the minute you post it there. This is a very simple table that allows you to get to their information, and here it is actually. This is live. So what do they call rooms, for example? Now we're getting a little techie. This is all gobbledygook kind of stuff, but to programmer, this means a lot because you can actually hit that and create an interface on a mobile device and say, what do you call these rooms? Here's a list of rooms. I don't have to type things in. So it allows you to mash this stuff together and build applications on the fly. And also down here at the bottom, there's a list of equipment. They have 2,000 different types of equipment. This is just a flat structure, but basically this was also distributed by CD, exam room table, all that kind of stuff. So anyway, that's that. And actually, one more thing before I leave that interface there, just to show you the human readable version of this. looks like this. So this is hitting the max.gov web server, opening up the user interface that allows us to go and search for dental chair. Let's see if that's going to come up like that. Dental, let's just say dental. Very simple tool. There's nothing magical about this. It's basically data that allows us to pull up and say, okay, this piece of equipment, this is a generic piece of equipment, a requirement of what type of dental chair needs to go into an exam room for this particular owner. Seems very simple, right? But this was very difficult to get to because it was not accessible before. But now, since there's an authoritative source, we can all be talking about the same ID, and we can be using that to make decisions and putting it into schedules and putting it into BIM and so on. So it makes it easy to kind of move data into that format. In the background, there's also data that's hidden. So it's not an all or nothing. This is a good thing about this not being a file exchange. You don't have to say, here's a BIM with all our data in it, but we can't put all the secure data in it, so we have to kind of strip it out and then give it a BIM. No, it's a transaction that says, I'm in the public internet here, and I want to access information. I'm hiding stuff below that the government sees that we can't see. And what they're hiding is some very simple things. They're hiding product-specific information because they can't go out and say, if you want to have a dental exam chair, you have to use a Stryker or Siemens or whatever. It basically has the data, and they strip it out and create a neutral version, and there's 2,000 pieces of equipment here. So this is the minimum viable BIM approach that I was talking about earlier. If we start getting lists like this, and we start guiding them towards a web service and putting it on the web like I showed with this master table web service. And this was a very interesting discussion for us. When we walked in the room with them and their IT security team was there, and we said, we think you should put this on the web and make it public. Imagine how long that discussion took to convince the government to open up their data to the public. Now, if this data was actually in Afghanistan, it's a different story. Then you need to log in, and you need it to be a secure network, all that stuff. But it's the same type of data. Here's the requirement, now it's coming out. Does that make sense? Okay. And then, because they have that web service, then you can build applications on top of that. So this is our web service now that we built on top of their data, including getting to lists. And this is for a specific building now. This is in a sandbox, so this is public, and you can actually access it if you'd like. I'll show you how to get to it. So I could say, give me a list of, let's see, what's a good one? Spaces in the building. This was actually used for the AEC hackathon last year that Paul Doherty initiated. So we got involved with the AEC hackathon in LA, and we put this out there. So this is a list of actual, so sorry, this is code type stuff here. Basically, it's a list of spaces in this clinic, in this building, which means I can hit that and say, I want to build an application on top of that to do stuff with spaces in that building. Pretty simple concept. And then, let's see, actually, so there's a bunch of different things you can do here, including saying, well, I want to see a floor plan of the building. It's a little frame that opens up. There's a floor plan of a section of that building, including the room that I'm looking at. So this is on the fly from the web. If stuff happened on the web that changed it, we would actually see it here. So back to the work orders for a second. So the work orders that you saw, that you submitted, I'm going to just look at it from the admin point of view. And again, this is not to say you should be using this work order system. It's just to say that you can build applications on top of this, including ones that are disposable like we did over the weekend. This particular part took a lot longer, but the first version of it was a weekend job. And these are actual live work orders that just came in from you guys out there. So Richard Taylor sent one in. And there's the work order. And I'm putting the admin hat on now. So as an admin, I can say, where's the location? Something's happening on this room right here, and I'm going to start. So we've seen these kind of functionality. I'm going to assign it to somebody else, and I'm going to do stuff with it, all that stuff, right? But the difference here is we also expose that with a web service. So the web service that we see here is what I showed earlier. And down here, work orders. All work orders in the building. Okay, so here's all the work orders that came in, and we saw that, who was that submitted one? I'll just search for a name here. Lewis submitted one, all you guys there, right? So if I go back to here and I search for Lewis, oops, did I do this right? Sorry, I'm kind of doing this on the fly here, but okay, maybe I'm not typing this right or something. Okay, there's one right there. I submitted one earlier. So this starts exposing the request. So this is computer code of that work request, which means you can build a whole new work order system or a new application on top of this. That's the way. You have to be fearless about sharing information. Obviously, there's certain rules. If this was a real building, it wouldn't be public like this. But by exposing this web service out there, it allows additional functionality to be built on top of and creates a bigger comfort level for these owners that want to make sure that their data can flow seamlessly. That's that Lego block along the bottom. It's a web service about work orders that have been submitted, which means you can build other Lego blocks on top of that analyze the work orders and look for patterns or whatever you want to do with it. That's the concept of all of this. Okay, so let's go back to this. We saw that. So the VA, Renee Tejan from VA says, the medical facility is the largest piece of medical equipment VA owns. If we can't manage the equipment and the facility, we can't manage our hospitals. And as we all know, there are challenges with these large owners. They're having huge challenges, which again is an opportunity. There's a huge pain point for owners of designing, constructing, and operating facilities, which means we as an industry can help to solve those problems. And this is an interesting diagram that was developed years ago at the Healthcare BIM Consortium at the National Institute of Building Sciences that said owners like Sutter, DOD, VA, Kaiser, all of them were in the room and said, how do we want to get to managing facilities and managing CAF and CMS systems and looking at patient monitoring and all these goals that we have on the right. We need to get here quickly. How do we do that? And the initial knee-jerk reaction is that we need to start building functionality and applications here to do that. Then as they started doing that, they were realizing, oh, wait a minute, the data coming out of design and construction is not consistent. So as we get data coming in, we have to clean it up and get it to work there. So there's a big pain point of what they call the red dot. Even with Kobe and all that still coming online, and they have existing facilities that are not in BIM, which is another important point. We can't wait for all facilities to be in BIM before we start making decisions about facility management. There's a ton of existing buildings out there, and there's new buildings coming online. So that cross-cutting that I did with the maturity wedge was about that we can start managing it even if you don't have a BIM, but data coming out of design and construction. Then they said, data going into design and construction, how we communicate our requirements to the design and construction teams is not very clear. The blue dot, the program requirements, is not very clear. So they honed in on what was the blue dot and said, we need to solve the blue dot about how we as owner organizations communicate out to the industry what our standards are to make sure that our naming and numbering of things makes its way into the BIMs and design and construction so it comes out of the other end. So it's kind of the initiating point of if we don't communicate clearly as owners what we need, how can we expect the red dot coming out to be consistent? So that's what we focused in on. So this was a project that was initiated by the DOD and VA, and I equate this back to the GPS, the satellite systems. It's almost that type of idea that if a large owner can make a decision and make a stand in the industry and help to push the industry forward, things can change pretty rapidly, even though this is DOD and VA. They used a server, a government server, which I was showing you earlier live. It's on max.gov. If you log into the server, you can drill down into more security levels, but it goes all the way up to public. So the same database on the bottom that talks about equipment is accessible to the public, but if you log in, you can see more information as you drill further into it. And they use a lot of open source and open standards tools, and they build also new functionality on top of that. They use all these different stack of tools. And this is what helps things move pretty quickly nowadays, is there's a lot of really great applications that you can kind of plug and play together to build a dashboard, for example, Pentaho and all these tools out there that help you do that. And the different types of databases that are being used allows you to kind of plug and play. That's the whole stacking thing that I talked about earlier. So essentially we're using that Lego stacking concept to bring the government data, the DOD and VA healthcare data that used to be in a black box, locked away and closed, and we suggested to take the green data, move it out and open it up, create a web service, and then build your own applications. This is the White House directive, right? Don't fuse your government data to your database. I mean, your government application to your database. Open up the data, build the application on top of that because other applications want to use that same data. So the green data that they use in that red box, which is called the Space and Equipment Planning System that defines the requirements for facilities, is also accessible now to the other applications down the line. And then we said, okay, in that database for the Space and Equipment Planning System, you have information like how big is an exam room? It's 120 square feet. What goes into exam room? These 30 pieces of equipment. What do you call those pieces of equipment? Here's a list of equipment. So once you put that data on the web, this is the equipment database here, and there are rules of what goes into the space. Then we said not only can you access that information, but you can actually start tying it into BIM on day one of the project. As you define the requirements, it means that you can start stacking things into the project and hand a BIM to the design team that has your data in it. So when they're designing, they're not typing things in and trying to align with your standards. That's the blue dot. If you get that alignment in place, then you can start going into design and construction and making that happen. And then the interesting thing that happened, and we predicted this as well in the strategic plan, we said once you do that and you show how you build your own applications on top of it like that, then you're going to have other vendors coming in and saying, hey, we can do the same thing. So we started with Revit families that already existed there that were tied to the data. We built a way to kind of automate that laying out of the rooms. Then ArchiCAD came along and said we can do the same thing because the data is accessible. We can align to that data. SketchUp came along. They put 3D warehouse data aligned with the objects that are the equipment. BIM object also tied into this. Atania, a non-BIM vendor. Atania is a database of medical equipment, product-specific data that says here's a Stryker's and here's a Siemens and here's the attributes about a Stryker and here's how much it costs and here's how big it is and how much electrical requirements it needs. Within a few weeks, they created a link to their data. So when the VA says we need a dental exam room with a dental chair, a generic dental chair, and the architect, the designer opens it up in Revit or Onuma, they can actually click on that chair and it goes and drills into Atania and pulls that data into Revit automatically. So if Atania data changes in the background, Atania is used by medical planners that make decisions, say, well, we should use a Stryker here and this there. They're having lists of information that allows them to make those decisions, and it brings this up to the user interface, which happens to be BIM. So all of a sudden, without going to Atania and saying, in order for you to be BIM, you need to understand COBie, you need to understand IFC, you need to understand Building Smart, you need to understand all these standards. No, that wasn't the case. They already had structured data in their format, and they linked with a very simple link, just an ID or a key back to the other object, which I'll show live in a sec, and then their data streamed in. So all of a sudden, their data now is in BIM. Very simple process in many ways. So we wrote this core concept for facilities for these different owner groups that we work with, talking about how you actually get to this. Think in terms of data being a strategic asset. Get away from black boxes. You're still going to have proprietary tools, and they're very important still, but the more specific discussions you can have with the vendors about how do I get data in and out of your application, not only with exchanges, but hopefully with web services. Create loose connections. In other words, in the past, it used to even be a marketing term. We're a tightly coupled application to this other thing over here, so it's very tightly coupled, and we're very integrated, which means you're very fused, which means it's very difficult to break that fuse. If you loosely couple and you just touch things, then you can plug and play different tools to that, and you can expand infinitely. So loose connections are important. You need structure, but you also need the loose connections. Embracing open standards are obviously important, so that's part of the recommendations. And the mobility and access has changed everything. Our perception of how we want to get to information has changed everything, absolutely everything in the industry. Think in terms of service-oriented architecture. If we're talking about cloud and big data, and the web services that I talked about, think in terms of that service-oriented architecture. Encourage an app economy. In other words, don't try and predefine everything. Allow other apps to be built on top of your ecosystem. Imagine Apple before apps were even around. They had only their Apple apps, right? As soon as they opened up their development kit and APIs and access to that, just the app economy just exploded, right? Absolutely exploded, because they can't imagine all the functionality that they need. Align the IT department with the organization. In other words, don't let IT drive your business decisions. That's always a problem, just across the board. Government, private sector, you walk into a room, IT is there, doing a great job, but protecting their turf of old tightly coupled systems that makes you dependent on them. So you have to reverse the direction, get IT to be your ally and work with that. And build and expand on an ecosystem. An ecosystem means that you don't have to rely on just one application and functionality. Okay, so this is where we're going to end up. The complexity factor. So we all know BIM and the building industry is incredibly complex, but if we think in terms of minimum viable BIM and starting point of little tiny chunks of functionality, the complexity can be solved pretty quickly. We're not going to solve everything, and we're not going to solve everything up front, but if we think in terms of that, it's actually possible to do. So this is how we broke the complexity down for VA and DoD. We said, okay, you have rooms and departments. What do you call rooms and departments? Okay, here's what they are. You have equipment inside those rooms, and you actually have data associated with that equipment. Okay, if you tie that equipment to things in the rooms, then you can actually start flowing that data from the web service that I showed you earlier into the model automatically. And also think in terms of if you don't have a perfect model. In fact, most of their models at the generic level are what we call LODC. We just called it C just for that discussion. But they have some models that are higher level of detail as they start going to further design. And obviously, that causes problems as a model starts getting big. But if we stay at LODC, they can start defining the requirements, and designers can do what they want with it. And they have a lot of objects that are LODB. There's no geometry at all, but there's tons of data associated with it. So out of their 2,000 objects that they had when we walked in the door with them, they had 1,000 objects that were in Revit level detail C. We auto-generated the rest of them, and now as they swap out and put new objects in, the idea is to keep the data in the background without losing geometry as you're working your BIM tool of choice. So the geometry becomes fluid in many ways, depending on what you're trying to do. In many cases, you do need the geometry. In other cases, you might not need it at all. You just want a list of stuff in a room like I showed earlier. Okay, so another live demo quickly here is, we'll go back to that website. You can actually try this out. It's seps2bim.org. This explains all of this. It shows where the web services that I showed you earlier, but it also has a series of utilities here that allow me to, and you could try this as well. I'm just going to type in my email and type in a dental exam room, which is DNTG1. There's all the room codes down here. I hit proceed. What this is doing is it's hitting multiple servers, collecting the data from the standards that are out there on the government server, collecting the BIM and geometry from our server, and then if I go back to my email and get my email for that, it's basically built it on the server, pushed it down to me in real time, click on the box. It went and grabbed the latest known location of equipment, the default location of a standard exam room. The owners like to spend a ton of money defining what they need, placed it in the room, built a BIM. You can take it out to Revit, ArchiCAD, SketchUp, whatever. We date stamped it with a date stamp, which said this is created today. So if you open this same link 2 days from now, it's basically like a freshness stamp, because this stuff changes. As the requirements change, you even see one right here. Since this room was laid out several months ago, there's been a new piece of equipment that was added. That's what that is out there. We call this a delivery truck. Even if a new piece of data shows up on the requirement, it basically places it in the room. So the designer still has to solve this, but it has all the pieces that are needed to build that. And if I take this out to SketchUp, you can do ArchiCAD, Revit, SketchUp. I basically downloaded an XML file. No geometry, just an XML file. And I go and grab SketchUp. We open sourced a plugin to SketchUp. Trimble took off with it, built more functionality on top of that. We asked them, okay, can you align with the object libraries that the VA and DoD use and are also in Revit, build the same version of them in SketchUp? They said, yes, we can. They did that. Then we said, okay, we see something called a 3D warehouse. Actually, we would like to place all the objects on the 3D warehouse, and when we go and import that XML file that I just generated on the fly, here it is right here. It's a very small file, 101 kilobytes, import. What this is doing is it goes and grabs that dimensional data, builds a room, and it's going to the 3D warehouse and grabbing those relevant objects and placing them in the room, and injecting the data that's coming from that government server that I talked about earlier. So on the fly, this is massive amounts of data. And if you imagine a whole hospital like this, obviously you wouldn't design a whole hospital in SketchUp, but you would use Revit. So Matt Anderle from AECOM actually did this test for the VA a few weeks ago, where he actually took a 500,000 or 600,000 square foot hospital of their requirements. And this amount of data coming in and automating that part of the process and being consistent with the owner data makes it easier for the owner to be more comfortable interacting with the design teams and makes us as an industry be able to deliver a more higher quality product back to the owner. This is just one sliver of what's possible. So there, it completed it there. And the same thing would happen if I want an entire department. So if I go to department here, this is all public now. I'm not hitting anything security related, because this is just how do I design hospitals and exam rooms. And I say, okay, this pull down, I don't have to make up these names. These are coming from the government server. So it knows that if I say I want a dental exam room and proceed with that, it's hitting the server, grabbing about 50 rooms, grabbing about several thousand objects and placing them in the rooms, just like I did with one room, for a single department. Then the next level up is for an entire project. It's all the same. It's all data in the background that's feeding in and out from that. So there it is. It's done. Same thing here. If I hit it on my... the reason we're doing this with email is because we're not asking for a login, so it's sending you the link. And we have an iPad version where you click on the iPad and it loads in on the iPad in 3D and all that. But this is actually an entire dental department with their data in it, with their objects in it, categorized by functional areas, and it's pulling the data in right now. And with the attributes, so there's the objects, the rooms. Notice some rooms actually have layouts, other ones just the equipment stacked in the corner because they didn't have a prototypical layout, but it still has all the objects in the rooms, which means you can take them into Revit and start doing the design work. The red blocks are what I described earlier, that there is no detailed geometry, but it still has a lot of data about this is a X-ray machine that goes in this room, and it has this bounding box area, and if you have a Stryker or whatever X-ray machine you want to swap out with it later on, that's fine. So that's the type of functionality and access to information, how access to information allows you to build these types of apps. And these are free utilities that are on the web. We use this as a way to point other vendors to so they can build their application and connect to it as well. That was the intent. When we built this strategy for this owner, we said if we build this prototype, put it out there, open up the data, then other applications can be built on top of it. Okay, so let's go back to, I think about 5 minutes, okay? Or is it wrapping up? 5 okay? All right. Okay, so what I described earlier about different vendors coming in, they started popping in. The SketchUp I showed, Revit I didn't show, but it's on the web. BIM objects tied into it as well. This happened pretty quickly. Once the data is there and there's an authoritative source, then other vendors and consultants can start saying, well, here's an Atania that I described earlier there. The medical equipment is there as well. They start popping in, and then we're talking to Foxblocks about their product and their link to BIMsmith. Revit, same thing. What I showed with SketchUp, the same thing happens with Revit. So if you open up the Revit or the SketchUp model, it has the same data inside it. And you can actually even keep them in sync if you wanted to. There's ways of keeping things and saying, okay, I want to do a quick movement on SketchUp and I want the same thing in Revit. AECOM, Matt Anderley showed us how they used to do things like with this VA project. They used to have to go and get a library and build a Revit model and manually add data to it and create a schedule. Now it flows in. So they actually showed a 500,000 square foot hospital. There's a guidebook on how to do this with tutorials and videos. Whoever's interested, you can talk to me later about how we can get to it. In fact, I'll tell you how we can get to it. But there's all these very simple steps. Here are the 8 steps that you do with that to get into to that. And we've been talking, like I said, to Foxblocks and BIMsmith about linking into this. And because we're both in the cloud, then it becomes very easy to say, okay, here's BIMsmith's wall types, and here's Foxblocks product. And if we look at a shape of a building and count Foxblocks products, and the Atania system that I described, the medical equipment, they did the same thing. Said, we have an Atania database. We see the SEPs to BIM data up there. We see some BIM coming out from Onuma, and we have Revit, SketchUp, whatever. We want our data to flow into these BIM applications, even though we're not a BIM application. So Atania data is linked to it as well now. And the Atania attributes stream in as you click on a product content on the web or on an iPad or in Revit or in Navisworks. You click on that, it streams in the attribute, which says Atania, all that stuff streams in. And the top attributes are coming from the DoD VA server. So it's a mashup of multiple servers streaming it into that user interface. This is what their user interface looks like, no graphical interface, but it has data associated with it and streaming into an iPad. And last few slides. So this is a quote that I love from Andreas Phelps. This is kind of unusual because, and this conference has been great, the amount of sharing that's been going on the last few days and the fearlessness of everybody that's here to actually share information and knowledge. Usually you tend to want, obviously there's a business need to keep things close to the chest and not share out. But the world we live in today, the faster you can show how you can connect out and share, the more opportunities that come to you. You're going to lose some with that, but if you don't do this, then you lose the opportunity and somebody else will come along and essentially do that anyway. So might as well share it and lift everybody's boats up. So that's an important idea in the technology world we live in today, and I think as an industry we have to think more in these terms because owners are starting to become more sophisticated. They're asking things and actually demonstrating here this level 3 implementation of what we did with this VA DoD work. More of this is coming out, and more owners now are actually looking at that. Other non-healthcare owners are saying, hey, we want the same type of thing happening with our data because we need to it's the same challenges that they all have. So don't reinvent the wheel. There's value and benefit in everything that already exists out there. You can actually start with what you have. Now's the time to get involved. Work with the owner data. Encourage other owners to join in and network among us as vendors and solution providers and consultants so we can share what's out there to create new opportunities and value and meet the objectives of the owner. And think about this open data and what started with this government satellite that was used for defense. And now we're playing Pokemon Go on it because of our positioning, location information, and we're able to do things, even play games. So it's an amazing time, an amazing world to be in right now. We're starting what's called, how many of you have heard of BIMstorm? We've been doing BIMstorms for years. We're going to take everything that I showed you about this healthcare facility data and educational data and other types of projects, put them into this BIMstorm, share this lifecycle playbook and the specific plays of how to work with web services and everything. It's free to join. It's starting end of this month, beginning of August, running into October, ending up at the National Academy of Sciences with VA, government, other government healthcare owners are watching in on it. So it's a perfect opportunity to learn how to work with this, to give us input on what works, what doesn't work, demonstrate your capability, and even network and find new opportunities. So I thank you very much for your attention, and if there are any questions, I'll take them and wrap up. But I know it's an overload of information. Hopefully I hit the strategy and the technology side okay, but any questions?
Is there any way you can show the slide again with the tutorial on how to do all of those videos?
This one?
No, it was back quite a few.
Oh, the tutorial for the, this one right here? Yeah. So we're going to put this into the BIMstorm. So we'll have all that in the BIMstorm, all the steps. We have actual files in different formats, Revit, the database that I showed you, SketchUp, all that stuff. And there's specific steps, and we tried to keep it very simple. It's step 1 through 8. Export the data from SEPs, import it into your application. Kind of what I showed with SketchUp, but with Revit. In this case, it was a Revit-specific workflow that we worked with AECOM on. And that'll be part of the BIMstorm as well. Any other questions?
Can you talk a little bit about the amount of energy and effort that went into creating a lot of the data on the back end? Obviously, there's a lot that was existing there, but
right.
Just even being able to collate it, understand it,
right.
build the services, not build the services, but just put the data in there.
Right. So the question is how complex and time-consuming was it to get the data on the back end? The data and the technology was almost dead simple. The policy and the shift in the business strategy was the most difficult thing, talking to IT to say to open it up. Because the data itself, like I showed you, is a very flat structure. It's basically a list of equipment, a list of rules of what equipment goes into a space. That can be built in hours. You can even put it on Google Docs in a spreadsheet and open it up like that as well too. But putting this stuff on the web, a database like that, is very quick. Then if you have the web service, and the web services are easy to kind of plug and play, things that are off the shelf as well. And then building the application like Atania that connected to it. We've had different experiences with different vendors. Some of them connect in minutes. They say, okay, there's a RESTful web service in JSON over there, and here's how I connect my application, and boom, they're pulling data in. So the first iterative baby step that we do, it's a very quick connection. Another slide that I didn't show, but you can see on the web, we did this exact same process with the California community colleges. They have 5,000 buildings, 120,000 spaces, a database. We prototyped it in a month to show, well, here's how it would look like if you connect your data to BIM and GIS and do the same thing that I was showing you here. Then they said, can we do it for another campus? And we said, no, let's do it for the entire state. Basically flipped a switch. The entire state's data was connected in because they had a database already about all their facilities. And the most important thing, I think, the most important lesson learned from this is not the applications or the standards in place or whatever, it's consistency. As long as that other database is consistent, I don't care what they call things, how they number them, whatever. As long as it's consistent, you can translate it and create a connection to it. So we're spending, in my opinion, way too much time, like Jeremy said, talking about building the standards. But if you create a simple way to do it, it can move incredibly fast. And we've done this with sensor companies. As long as that other data is open, that's another big step that takes a lot of time, a lot of times. Often is you go to a vendor or a consultant and they have data and they say, yeah, we're interoperable, we can work with it. It's okay. The first question I ask is, okay, show me how I can connect to it. Oh, well, we'll have to get our team. Okay, that's going to take a long time. The ones that already have it, they say, here's our API, here's our web service, here's the JSON. You can connect to it. Even we were doing testing with some of the vendors yesterday in the content summit. So the ones that have that access, then it moves very rapidly. And it's very quick to build the first version of that. Now, obviously, you scale from that, but anyway, so I think that's...
Yeah, standing up nice and subtle, like turning the lights off when it's time. Yeah, thank you very much, Kim.
Thank you.